Hi, I'm Roger Baugher. I will be chairing this session regarding yards and terminals. I'll make the first presentation. There'll be 4 other speakers, and the topics will range from modeling yard operations, developing using yard management tools, and analyzing yard performance. We have, as I say, 5 speakers, not a lot of time for each, and so I'll keep my own remarks brief so the other presenters have adequate time. I've also taken the liberty to change the order of the presenters relative to the original schedule to provide a smoother transition. In this and the following slides, I present the abstracts that were presented to inform for the session. My talk will be the first. I'll be dealing with flat yard simulation using AnyLogic, which is a package capable of depicting railroad movements. Yahi Zhao from University of Illinois will then focus on use of AnyLogic for hump yard simulation. Jeremiah Dernberger of Wabtec Corporation will speak about his efforts on development of yard planning systems. Tim Robinson of Canadian National is a field and staff individual who has extensive experience both in simulation and in actual yard operations, and he'll speak about how we might improve the way we represent yard operations in our line capacity and other models. The next presentation was written by Nilfar Minbashi and Marcus Bolin. Nilfar will be making the presentation, and he will discuss machine learning algorithms for yard departure prediction. I first became interested in analysis and modeling yard operations about 10 years ago when I was in the service design department at BNSF Railway. There was a yard in South Texas that was performing poorly, and I was charged with development of some tools that would assist in the analysis of the poor performance. At the time, I chose the AnyLogic software package because it has a module that really understands rail operations, which they call their rail library. Recently, I've been working with Cedar AI, which is a company that's been developing AI software to improve yard operations. They have focused on the functions that are currently served by yard masters, that is, organizing the sequence of switching moves in a yard. The company has developed a product called OptiSwitch for flat yard switching, which identifies the best sequence of pulls, shoves, kicks, and so on that accomplishes a specified objective given the track layout and the current yard inventory. The gentlemen on the right, as they retire, take years of experience with them, and they are being replaced in most cases by people hired off the street with little railroad experience. This requires their replacement with some new tools to improve the yard operations. In my demonstration on the next slide, I have taken output from OptiSwitch and designed simulations to visualize the switching sequence and provide feedback on time and solution quality. And here's the demo. So let me introduce the layout of this visualization. At the left here, we have the process time and the elapsed step time. Process time is the total time that the complete switching sequence is going to take, and this is the time for each step in that sequence. What we have up here is the objective that we're trying to obtain. So we want AABBCCC built on track 2. We're going to use a total of 2 tracks, and the number of moves, as you can see, is 4. So down here we say, for example, the first step is to pull 1 car from track 2, shove it to track 1, and then we're going to hold on to 6 cars. So I'll start the animation at this point. You can see that the groundman is walking from the engine where he was back to the rear of the first car, where he's going to uncouple the cars, and he's then going to ride the tail car so that he's in position for the coupling on this track. I'm going to speed this up so that we don't take too much time watching what are slow movements. This is, by the way, a scale representation of a yard ladder based on the actual geometry of a yard. So the times involved and the distances and so on are representative of a particular yard. So here you can see he shoved 6 cars in, and he pulled 4 cars, so he moved ahead 2 cars. So now he's there to prepare for the coupling. He's going to walk back up to the first car and ride that, and he's going to shove into track 2, and he will clear the cars and the locomotive from the clearance point, and he's now done. So what we see here is it took him a total of 8 minutes and 54 seconds. Each step was recorded over here. And as you can see, our target was AABBCCC, AABBCCC. Well, OptiSwitch considers many alternatives. I've selected 5 here for examination. So you can see the table shows for each alternative the number of moves, the number of tracks used, the time required, and the cars pulled. Number of moves varies from 3 to 5. Tracks used vary from 2 to 3. To me, the most significant thing here is that the time varies dramatically among these alternatives. And I've examined these alternatives. They're all practical and reasonable. So the key here is to find the alternative which best suits the objective. What we see is alternatives 2 and 3 come in at 5 minutes and 45 seconds, and alternatives 4 and 5 come in at almost 9 minutes. That's a difference of over 50%. So the selection of a good decision is critical to the operation of the yard. The last column shows the number of cars pulled. You can see that ranges from 9 to 15. And this is significant in the impact it has on acceleration, deceleration while pulling and shoving cars, and also is a measure of the amount of carbon emission. So I conclude that tools like OptiSwitch are increasingly needed given the drive to cut manpower and the retirement of skilled yardmasters and conductors. I think beyond that, once these tools are in place on yards, they can communicate with one another, and adjacent yards can develop plans that minimizes congestion at any specific yard. If you're interested in knowing more, here's a link to my recent webinar on yard switching. If you're interested in visiting the other presentations in the webinar series, then look at this link on the bottom. If there's any interest in reaching me directly, I can be reached at rwbaugher@gmail.com. And I appreciate your attention. We'll take questions at the end. The next speaker is Yahi Zhao of University of Illinois.